Okay, let's look at numerical number 2. A fixed pulley is driven by a 100 kg mass falling at the rate of 8 meters in 4 seconds. It lifts a load of 75 kgf. First of all, let's try to draw this. So let's try to understand. We have a pulley. On one side of the pulley, we have a load. Now the load given to us is 75 kgf. And on the other side, where you apply the effort, we have a mass. Now remember, the mass is falling down due to gravity. This is a mass of 100 kg, and it is falling down at the rate of 8 meters in 4 seconds. Now we have to calculate first one, the power input of the pulley taking the force of gravity on 1 kg as 10 newtons. So we can take the mass over here. For 1 kg, the force required is 10 newtons. So for 100 kg, the force required will be 100 multiplied by 10, which will be equal to 1000 newtons. So the effort over here is 1000 newtons. Now let's look at the load over here. The load is given in kgf. We have to first of all convert the kgf into newtons also. 75 kgf. We know 1 kgf equals to 10. We'll assume 10 newtons over here. So 75 kgf will become how much? Cross multiply, say divide. So we'll get load equals to 75 multiplied by 10, which is 750 newtons. So now we have our load and we have our effort. We have the time and we have the distance. So let's try to find the first one. A part is to find the power input of the pulley taking the force. Okay, power input. Now power equals to work done upon time. Now in this case, we have to find what is the power input. So our input is always the effort. So we have to find what is the work done by the effort. And based on that, we'll find what is the power of the effort. So now let's see, work done by effort equals to, again, force multiplied by displacement. Now in this case, our force will become in effort. So effort multiplied by displacement, which is equal to, effort is 1000 newtons and the displacement is 8 meters. So 1000 multiplied by 8, which is equal to 8000 joules. This is the work done. Now we have to find what is the power. Remember, power equals to work upon time. So 8000 work we just found out, 8000 newtons divided by the time given is 4 seconds. 4 ones are 4 and 4 2000 times. So power equals to 2000 watts. Now let's look at the second part. The height to which the load is raised in 4 seconds. So we have to find what is the displacement over here. Displacement of the load. Oh, sorry, I actually missed the second part. There is the B part over here where we have to find what is the efficiency of the pulley. So let's try to find what is the efficiency of the pulley. Now, we already know the formula. Efficiency equals to velocity ratio upon velocity ratio. Efficiency equals to MA upon VR. So let's try to find what is the mechanical advantage for the system. Mechanical advantage equals to, remember, our load was 750 newtons and effort was 1000 newtons. So our velocity ratio equals to 0, 0, 0, sorry, this will become 3 upon 4, which is equal to 0.75. Now for a fixed pulley, velocity ratio is always equal to 1. So now let's try to find what is the efficiency. Efficiency equals to 0.75 divided by 1, which is also equal to 0.75. This is the efficiency of the pulley. Now let's find the third part, which is the height to which the load is raised in 4 seconds. Now remember, in a fixed pulley, the distance moved by the load is always equal to distance moved by the effort. If the distance moved by the effort is equal to 8 meters, then the distance moved by the load is also equal to 8 meters.